I definitely have a thing for cold places. I love being cold. I love it. I hate being hot. I've worked as a climbing ranger in the National Park Service and as a mountain guide for a guiding company. And then in 2010, it was sort of the next step for me to lead a really big climb, and that was Pinnacle Peak in the Himalayas. It had never been climbed by all women. We climbed it on our own, and it was probably one of the hardest places in the world to do that. My love of cold places definitely has extended into my science. I'm most interested in how sea ice in the ocean around West Antarctica has changed in the past, because West Antarctica is incredibly sensitive to warming surface ocean temperatures. We've already seen that slight warming has caused a lot of melting along the coast of West Antarctica. And so in the future, as this process continues, ocean water may be able to penetrate far below the ice sheet and potentially lead to some sort of catastrophic collapse of the West Antarctic ice sheet as a whole. So we have records from satellites that take images of sea ice over the last 20 or so years, but before that, we really have no idea what sea ice looked like. We went up to 18,000 feet and saw that there were really only two ways to get up on the summit of Pinnacle Peak: this easier standard route and a nearly vertical ice face. We went to see if the easier route was going to be possible, and it was clear that if we went up this way, it was very likely that we could trigger an avalanche that we would get caught in. So the three of us sat there beneath this near vertical face, knowing that was the only way we could go up. It was the first time where I ever had the thought, oh no, maybe I'm in over my head. I'm developing a method for reconstructing sea ice in the past by using the West Antarctic ice sheet itself. Every summer in the southern hemisphere, sea ice breaks up, and it's the first time that year that the upper part of the ocean has seen sunlight. And so all the little plants of the sea, the phytoplankton, bloom when they see the sunlight. And they give off a chemical that eventually becomes methanosulfonic acid, or MSA. And this MSA gets carried by the wind, and it snows out onto the ice sheet. So year after year, bloom after bloom, and snowfall after snowfall, the MSA gets laid down in layers on the ice sheet. So the MSA is a direct recorder of what is happening with the sea ice off the coast. I want to look at these layers in the ice back through time, and the way to get this record out of the ice sheet is to drill or to dig. We hand dig the snow pits. Generally 2 people digging for half a day until you've got a snow pit that's deep enough and big enough to sample for MSA. We also drill ice cores. And once I have these cores, I can cut them up into little slices and melt them and measure the concentrations of MSA. And I'm really excited about my results. So MSA can tell us about the extent of sea ice and how it's changed over hundreds of years. It was possible that this method was not going to work, and it did. I'm not exactly sure how the 3 of us together decided, but we decided to give it a shot to go up that face.
Okay, front person's just going to tie in. Do we just want to be 25 meters apart?
And it took 2 days. It was pretty tricky and difficult, but I just remember the second that I thought, we're going to make it.
This is why we're here.
Sometimes you have to just try things even though you have no idea what the outcome is going to be.